take a moment just to be sure everything is running well before we get started today. As we wait, feel free to put any questions you have in the chat, and we will have a time for Q&A after the end of Carl's presentation. I'm also loving seeing where everyone's coming from today. Oregon, Germany, India, Minnesota, that's where I hail from. So hi, Brent. New York, Paris, Washington, France. This is just amazing. Our community is all over the globe, and people need MTLS and device attestation everywhere. So it's pretty awesome.
That's great.
All right. I think we are good to go. I am Janessa Peterson. I do all things marketing here at Smallstep. We are making Zero Trust a reality every day through authentication, which is what we're here to talk about today, using an awesome new technology called device attestation. Just a quick reminder to send questions in the chat as you have them. We will probably not do them during the actual tutorial that Carl is giving, but we will get to the majority of them after Carl's tutorial is over. So, Carl, I'll hand it over to you.
All right. Thanks, Janessa. Hey, everybody. I'm Carl Tashain. I'm an off-road engineer at Smallstep. And so what we're going to do today is I have a YubiKey here. And what we're going to do is set up a gateway host into a homelab that uses mutual TLS, client certificates, and the certificate and private key are going to be on the YubiKey. And we're going to use ACME device attestation to get the certificate from a Smallstep CA. So there's a lot in there, but I'll unpack some of those terms in a second here. And Janessa is going to post, there's a blog post tutorial that goes along with this. So Janessa is going to put the link in the chat if you want to follow along there. So for agenda today, we're going to start with a little background. Then we're going to play around with the PIV functionality on YubiKey, which is an app on YubiKey that gives it smart card functionality. So like normally you might be used to using YubiKeys for U2F authentication on websites. This is like a whole other, PIV is a different world. And it's just another piece of functionality on the YubiKey that we're going to be using for the tutorial today. And then we're going to set up a certificate authority. We're just going to configure an ACME server that we're going to use to get a certificate onto the YubiKey. And then we will set up and test a Caddy server that'll be our gateway. And then we'll do a little Q&A at the end. Okay, so getting into the terms. So first of all, mutual TLS is, if you're not familiar with it, is mutually authenticated TLS. Typically, when you're using the web and you go to google.com or something, you're using server TLS, it's server authentication, right? So your client is authenticating google.com. It's using the certificate that google.com presents to verify that you're actually talking to Google. With mutual TLS, you add on client authentication. So in addition to the client authenticating the server, you also have the server authenticating the client. And that's going to be our authentication scheme into the homelab. It's pretty different from having a login page because you're not even loading a web page. You have to authenticate before you can even load the page, right? It's all happening on the level of TLS at the protocol level rather than inside of a web application or something. So that's mutual TLS. The smart card support on the PIV support on YubiKey, I just want to define that for a second. This lets you store private keys and certificates on the YubiKey itself. So there's these slots. You can import certificates. You can generate private keys on the YubiKey. These are hardware-bound private keys. So they're not exportable from the YubiKey. If you generate a hardware key, a private key, a key pair in the YubiKey on one of these slots, you can't export it. So that's great because somebody could steal the YubiKey physically and use your private key, but they couldn't take the private key from you and make a copy of it. So we're going to be using that. We're going to be using hardware-bound private keys in this demo. And then we're also going to be using device attestation. So this is on YubiKeys, but it's also on other hardware devices like TPMs. So the idea of an attestation is just a fact, a statement of some sort of fact that is digitally signed by a third party or some sort of trusted party, right? And in the case of a YubiKey attestation, we'll see it in a second, but the YubiKey is capable of attesting the contents of the public key that's associated with our private key that we're storing in the PIV application. And it'll also provide some more information. So like the serial number of the YubiKey is part of an attestation. And we'll see that in a second. Finally, we're going to be using the ACME protocol, which maybe you're familiar with from just getting certificates from Let's Encrypt and the Web PKI. ACME last year added a new challenge type called Device Attest 01. And with this challenge type, you can use these attestations from devices to get certificates from an ACME server for the device. And it's usually the certificate is associated with some kind of hardware identifier. So in the case of the YubiKey, you could get a certificate. We're gonna get a certificate that uses the YubiKey serial number. This is also this device attest 01 challenge type is so Apple's added support for it in iOS 16 under the term managed device attestation. And so it's a new way to do to get certificates to Apple devices as part of like an MDM workflow. So it works on all kinds of different devices. And all right, so we should just get right into it now. I'm going to put the YubiKey in. And I'm using this is a utility from YubiKey called YKman. That's just a YubiKey utility. And we're going to generate a private key in the YubiKey in slot. The slot number is 9A. And this is a key slot that we can use for client authentication in web browsers. So all the web browsers know to look at this slot when going to a website to check and see if there's a key and a certificate in the slot. So when we generate this key, it's now generated on the YubiKey and we get back the public key portion. And now let's make one of these attestation certificates. So I'm gonna create an attestation certificate and then I can take a look using the step CLI command. This is our open source CLI tool. You can take a look at this certificate that we just generated. So it's a pretty interesting certificate. It's got, let's see. It's got,
Hey, Carl, we're not seeing the utility on our end. So I'm going to remove and re-add your screen.
I can stop screen sharing and start over again. Yeah. Do that. Let's try and get, sorry folks. Let's try and get the screen sharing working here. Okay, I generated the private key here in slot 9A on the YubiKey. I got back the public key portion, and then I ran this command to create an attestation certificate. There's a CA on the YubiKey that's creating this attestation certificate, and we're going to see that in a second. And then I used the step CLI command. This is our open source tool. This is like a general tool for managing certificates, working with certificates, and also for working with our open source certificate authority, step CA, and our commercial certificate manager hosted CA. Okay, so we take a look at the certificate, very long-lived certificate. It's issued by a CA called PIV Attestation. This is the one that's on the YubiKey itself. Subject is Attestation 9A. This public key is the key we just saw above. And then we have some information about the YubiKey itself, right? We've got the firmware version, this is the serial number of the YubiKey, key policy stuff, and what type of key it is. And then it's signed by this Attestation CA. Now we can verify this back to a root of trust that is hosted by YubiKey. So if I download the YubiKey root from their website, take a look at that certificate. This is their root CA. And the YubiKey itself also has a CA on it that's the link between the root and this attestation certificate we just generated, the intermediate. And it's in a special key slot called F9, and that just comes with the YubiKey. So if I take a look at that one, you can see this one's issued by the root we just downloaded. And this is the certificate that signed, or this is the key that signed the attestation certificate above. So now we have a complete trust chain that anyone, anywhere could verify, right? And we'll just verify it with the step certificate verify command right now. So you can see it doesn't return anything, and that means it verified the chain successfully. This is great because with this attestation, a CA can now use this. So our ACME server is going to use this attestation certificate along with some proof of the existence of the private key being in my possession to generate a certificate for this YubiKey. And one nice thing about these attestation certificates, in the case of YubiKey, you can only generate this attestation certificate for a private key that is generated on the YubiKey itself and not exportable, right? So I could import a private key into this YubiKey slot, but it would not allow me to do an attestation of that so just the existence of this certificate is, and then the full proof of the trust chain is proving that not only do I have this private key, but it's not exportable from the YubiKey. So hardware bound. Now we're going to do so we'll take care of this certificate, the CA side. We're going to set up our ACME server. What I've done so far is I've just created an account on Smallstep Certificate Manager, and I created an authority there. So I created a DevOps authority. If you want to, if you don't have an account on Certificate Manager yet, you can create one and you can have up to 50 endpoints that are for your home lab for free and manage the certificates on our hosted CA. Or if you want to self-host, you can run your own CA at home and use our Step CA open source certificate authority. And these commands, I think they're all pretty much the same, regardless of whether you use a hosted CA or a self-hosted. Okay, I'm going to create this command. Oh, it's kind of hard to read. This command creates the ACME server. There we go. In the world of Certificate Manager, we have these provisioners, which are ways of getting certificates from Certificate Manager, just different methods. You can use OIDC, you can use JWK. In this case, we're going to create an ACME provisioner, and we're going to configure it to use device attest 01 challenge type for device attestation. And now now that I've created that, we have a little bit of a problem here, which is that anybody on the internet with a YubiKey could now get a certificate from the CA. So we need to add a policy that restricts the certificate issuance to just my YubiKeys. So I added a policy with my YubiKey serial number in it. And I could do, this is just like an allow list. So I could do multiple. If I have several YubiKeys, I could add them in. I could also add a policy for just like my home labs, DNS. If I want to create host certificates for my home lab, I can create a wildcard policy for that. Now that that's in there, you can see the resulting policy we have. We should be good to go on the server side in terms of the CA. I think we can get a certificate now. I'm using step CA certificate command to do that. And I'm also using this plugin for the step CLI called step KMS plugin, which is a plugin for a step command that lets you use hardware devices, like whether it's a YubiKey or a HSM. And we're going to use this ACME attestation challenge. We're going to use the key that we already generated earlier in slot 9A, and we're going to create a certificate. So let's try that out. Great. Okay, so we have a certificate now. Let's take a look at that. All right. So now this certificate has been issued by the Smallstep CA. So it's about a month duration there. And then the subject is my YubiKey's serial number. And this public key is the same key as we saw above in the attestation certificate. We also have this is like a special X509 attribute extension for the permanent identifier, which is the kind of abstraction for this could be any kind of device identifier. So if it's an Apple device, it would probably be a different format. But in the case of a YubiKey, it's just the serial number. And now that we have that, we can import it onto the YubiKey. And there's a certificate slot that parallels the private key slot, right? So now I've imported it onto the YubiKey. I can just remove everything that's here on my machine because I don't need any of those files anymore. And I can take a look with this PIV info command, see what's on this, see what's in our certificate slots. And here we have the certificate imported into slot 9A. So with that, we're ready to go on the client side of things. So I could take this YubiKey now and use it for client authentication. And all like the common web browsers support this now without, you don't have to like do any extra configuration or anything. You can just plug a YubiKey into any system and the browser will pick it up and use the certificate and key if it can. And so now we just want to set up the server side so we can do a full test of this whole thing. So I've got a VM here. I haven't done anything on this VM. It's just a fresh VM. So I'm going to start by installing Caddy server. This is going to be our gateway host server. And I'm just using the install instructions right off of the Caddy website. So just that, these are just those commands. So just wait for that to finish. And this is just an Ubuntu VM. All right. And then I'm also going to install the step CLI tool using the instructions off of our website. So we can bootstrap this VM with the CA. So I'm going to do that now. I'm going to bootstrap the VM with my Smallstep CA. So now just saved my root CA certificate locally. The next step is to configure Caddy. When I installed Caddy, I just got a default Caddy file. I'm just going to remove that and stop Caddy. And I'm just going to paste in a new Caddy file that's going to set us up for mutual TLS. And let's just walk through this. This is going to require client authentication if you include this MTLS required block here. This trusted CA cert file is something we're going to have to put together as a little certificate bundle that will allow the server to complete the chain for client authentication. So this file is going to have both the root CA from my Smallstep certificate manager authority and also the intermediate CA. And then my YubiKey has the leaf certificate on it. So with all three of those, we should have a full chain and be able to connect. And then this is my virtual host for my home lab. Now we're just going to have it like do a little hello world here as a response and require mutual TLS. But for your home lab, you probably want to use this and then reverse proxy whatever internal services you want to be able to access from the outside. And for this, the other interesting bit here is that Caddy is going to get a certificate on the server side for my host from Let's Encrypt or one of the other web PKI CAs. So I'm going to have a publicly trusted certificate on the server side, but I'm going to be using a certificate from my private CA on the client side. So the last step is we need to put together this certificate bundle. And this is really just, it's just this one file, right? ca.crt. I have to get the intermediate certificate, which is a little tricky, out of my CA. But what I end up with is I have the root for my CA, and then I have the intermediate. And I concatenate them together, the intermediate first, the root second. It turns out this order is really important. It has to be intermediate and root in order for web browsers to complete the chain. So this can just be a static file. And then now that we have that in place, I should be able to start up Caddy and be good to go. Let's take a look. Looks like it went to Let's Encrypt. It got a certificate for my host. And I've got this host set up in DNS. Everything looks good in terms of the logs. So I think we can go over to web browser now and try it out. Let's see. So I have the YubiKey here. I'm just going to insert the YubiKey and open up the web server we just created. And can you guys see this prompt? You might not be able to see this prompt, but Chrome opens up. I think it's technically another window, so it's not showing in the stream. But Chrome opens up a window that says select a certificate, and it's picked up the YubiKey. It sees the certificate on there, and it sees that it can use it in this TLS handshake. So I'm going to just accept that. I'm going to say yes. It's also asking for the PIN over here. I'm sorry, that's not visible in the stream. But I type in the YubiKey's PIN as a second factor. And then when I click OK, I'm authenticated and I'm in. Now, if I remove the YubiKey, I'm going to close this Chrome window and we'll open up a new one. We can also just try this out on your side. If you try to visit that URL, carl.lab.step.toys, you'll see that, let's see, here we go. Okay, you'll see that it's just going to give you an SSL error because it can't authenticate. So now the YubiKey is not in the machine anymore. Yeah, so next steps from here, that's the basic setup in terms of mutual TLS into your home lab. Things you would probably need to do at this point. Oh, also, I wanted to mention this works on iOS too. You need the YubiKey Authenticator app, and there's a couple extra setup steps, but it's nice because with the NFC, if you have an NFC YubiKey, you can use NFC to sign the TLS connection, and yeah, it'll work on mobile devices. So next steps, things that you would probably want to do at this point would be like setting up the reverse proxy piece to proxy services from your home lab. Caddy has some nice tutorials. The Caddy community has some nice tutorials on how to do that. And you might need to set up, you'd want to expose the HTTPS port through your router so that you can actually access this Caddy server, this gateway server from the outside. And you'd want to set up some kind of DNS. You might need to, like in my case, I have to set up dynamic DNS to access my home lab because my IP address here at home keeps changing. There are some really good tutorials on all of those things linked from the blog post. So yeah, I think that's it. We can go into Q&A at this point.
That sounds great. Thank you, Carl. I actually had no clue about the YubiKey app as well. So I'm like, I know what I'm doing the rest of my day. That sounds amazing. There's just so many really great ways to use device attestation. So like Carl said, we have time for Q&A now. So get your questions in the chat now, and we can have Carl answer all of them that we have time for. We have quite a few questions from the community already. I will start with one that we got previously. I think you touched on this as well. And I saw someone comment in the chat about it too. So I just think it'd be, again, like really great to drill home. So if I lose my YubiKey, which admittedly I've done before,
We all have.
it was just a personal one, but can someone get into my home lab? What happens if I lose it? Should I revoke the certificate in Smallstep Certificate Manager? What's the next steps if that happens?
Yeah. So can they get into your home lab? Yes. Will they get into your home lab? It's unlikely. Like one reason I think it's unlikely is that the certificate that you end up generating there's no URL, right? So they wouldn't know what URL to go to get to your home lab. But that's a real concern. If you lose the YubiKey, then yeah, somebody can definitely use it, especially if you haven't changed the PIN and you're just using the default PIN. That PIN is always there as a second factor. That's a nice feature. If you lost the YubiKey, you would definitely want to remove the policy on the CA side so that you don't, so that whoever has a YubiKey can't get another certificate from your CA. Yeah. I think that pretty much covers that one.
Yeah, I would love, somebody else asked earlier, could you use longer lived certificates? We are going towards shorter lived certificates for better security and better automation. So you're not having to like manually renew your certificates. But could you use a longer lived certificate if you want?
Yeah, you could. And I think there's a pretty good case for doing that, especially with hardware bound keys. And yeah, with the short-lived certificate, what you get is if the YubiKey is lost, you get passive revocation, right? So in other words, when the certificate expires, it's just going to stop working. And as long as they don't have a way to renew or get a new certificate, then there's no more access. With a longer lived certificate, it's a little bit more challenging. Like you might, depending on your environment, you might need to set up some kind of active revocation, like OCSP or CRL. And there's just more infrastructure involved in that. And it's a little more complex deployment. So there's trade-offs for sure. But the nice thing about a longer lived cert is that you don't have to refresh it as often.
Yeah, definitely. Carl, I'm just going to give you a few seconds here to just catch up in the chat. Look
Yeah.
at any questions that have come up. and answer them in whatever order you want. Just for
Sure.
everyone in the chat, we did put the blog post. So there is a blog post with a tutorial in it that Carl went through today. So don't feel like you have to remember all of these commands, all these prompts. It is all in the blog post and the tutorial. Also, this will be available via replay. So if you go to that same link that you used to register, you can also, oops, sorry, I think I might have glitched out there for a second. If you go to that same link that you used to register, you can also replay this webinar at any time. So you don't have to memorize everything that Carl just said. All right, I'll let
Okay.
Carl take it away with some questions.
Okay, so one question was, you typed a policy to restrict the provisioner from generating certificates for only your YubiKey. How would you update this policy if you were tracking dozens of YubiKeys? So we have a different approach. For the home lab context, the policy is a great way to do it. But when you have dozens or hundreds or thousands of YubiKeys that you need to manage, we have a feature called inventories in Certificate Manager. And what the inventories feature does is it lets you map all those YubiKeys to user identities. Like you could actually have, instead of getting a certificate with just the YubiKey serial number on it, you'd get a certificate with an email address of the person who, has the YubiKey. So you can enrich certificates using those inventories. And that's really what we recommend for larger deployments. And on the self-hosted side, you can also do that using our webhooks feature. What you'd have to do is write a webhooks server that lets you make that mapping between your users and your YubiKeys. You'd have to set up like a database for it and stuff. Yeah. Let's see what other questions we've got here. Let's see. Will this work for mobile device-based access? Yeah, I think I answered that one already. Can you do similar storing SSH certificates on the YubiKey? YubiKey is designed around X509 certificates, so that one, there's some hacks you could do. Like YubiKeys have these like arbitrary slots that you can put data, just random data, whatever you want, files into essentially. So you could use that as a way of storing like SSH key material, but it's not, you need some tooling around it to make that smooth, right? The nice thing about using specifically TLS certificates in slot 9A is that all the web browsers are going to support it out of the box. And that's as of 2021. So that's a relatively new development, like that the web browsers are all just supporting this without having to like add like libraries and plugins and stuff. How many slots does a YubiKey have? I think it's about a dozen or so slots. Can you store more than one in the 9A slot? No. So every slot is just one certificate and one private key. And the challenge of this is that I wish you could store more than one, because this is why we have to put the intermediate and root on the server side to complete the chain. If this slot could store both the leave certificate and the intermediate, then it would make the server setup a little bit more simple. You authenticated through Chrome and then removed the key and couldn't authenticate. Why didn't Chrome have the certificate? Oh, I closed the window. So there was like a connection already established. Chrome they could have cached the certificate from the initial authentication, but you need the private key that's on the YubiKey to sign some data as part of the TLS handshake. So it's not just the certificate that makes the connection work. And that's why when I removed it, it doesn't work anymore. Do we have any others here? I think that's about it. Yeah, if anybody has, can this be made to work with the YubiKey U2F key? I don't believe this will do the key signing necessary. Okay, if you have what's called a Yubi security key, that only does U2F, that won't do, those don't support PIV. There's a feature matrix on YubiKey's website that has all this on. What you're looking for is a YubiKey with PIV support.
Which I believe are all the 5s, correct?
All the 5s, yeah, but the security key does not have it.
The security key doesn't have it. There was one other right above that one about setting up a single Caddy server. I don't know if you wanted to comment on that at all.
You set up a single, you can probably reverse proxy to many homelab ads. Yeah. Caddy instance for every, oh, okay, that's a great question, actually. You wouldn't need to run necessarily multiple Caddy instances for each app. What you could do, you could do that. But another way that I was thinking you could do this is just setting up multiple DNS CNAMEs to your home lab for each app that you want in your home lab. If you want them all to work on like the apex or sorry, on the root level of the, you want to host your apps at the root rather than a subdirect, what do you call it? In a subdirectory in the URL. You could set up virtual hosts and have several of them that are hosted by one Caddy server, and then have each of your virtual hosts with different DNS names just do a single reverse proxy to one of your home lab apps.
All right. I think that's all the questions that I have seen. Thank you, Charles, for being another YubiKey expert in the chat. That was awesome. Yeah, I think.
Oh, can I say one more thing though? 9A is like the key slot. Like there are a bunch of slots on these YubiKeys, but 9A is the one that all the browsers are looking at. I did a bunch of testing on different web browsers and different ways of setting this up to figure out like what the smoothest workflow was. And yeah, 9A is the magic number.
Interesting. I wonder why that is.
Yeah, these browsers are Firefox looks at the other slots, but most of the browsers don't.
Interesting. Very cool. All right. So we will give you your 20 minutes of time back. If you want to continue having conversations about how to use Smallstep open source and about how to use this technology within your home lab, we do have a Discord channel. You can find that at the bottom of any of our website pages. So smallstep.com, just scroll down to the bottom. You can find our Discord channel there. We also there's just so many use cases for device attestation. I feel like we are just starting to get into all of the places that we can use this amazing protocol. And a lot of that has to do with devices and hardware bound authentication. And so YubiKey is just the start of it, right? If you're interested, anyone in the webinar, anyone watching this on YouTube afterwards, if you're interested in using hardware bound authentication in other environments other than just your home lab, for example, your enterprise environment at your company, just reply to the email that we'll be sending out after this, and we can get you connected to our team and on the road to practical zero trust. We are super excited again about device attestation. I think everybody here is really excited about it. We had a record number of signups for this webinar, and it's really, when we talk about practical zero trust and making zero trust a reality in every environment, device attestation is a huge part of that. So if you want to see it in other places, let us know. Thank you again, everyone, for coming, for being a part of this stream, for being a part of our community as we change the landscape of authentication every day. And we will see you all again very soon.
All right. Thank you. Thanks, everybody.